at the PHELIX beamline at SOLARIS, the Polish national Synchrotron Radiation Facility, which is partner in the CERIC consortium. The PHELIX beamline uses soft X-rays and variable light polarizations to unveil the electronic, chemical and spin properties of investigated materials such as topological insulators, superconductors, semiconductors, thin films and multilayers or bulk compounds. It contains several methods to widely study the nature of matter. Soft X-ray angle-resolved photoelectron spectroscopy reveals the electronic band structure with bulk sensitivity in three-dimensional K-space. For magnetic materials, it might be combined with the direct information about the spin texture using PHELIX spin detector and the circular dichroic measurements also containing spin information. Coexistence of those two methods in one UHV system is unique. In addition to X-ray photoelectron spectroscopy used to determine the chemical composition of samples, the resonance photoemission studies are carried out based on the photon energy dependence of valence D and F states of the strongly colorated electron systems reflecting their bulk electronic properties. The last available technique is X-ray absorption spectroscopy in two measurement modes: total electron yield and total fluorescence yield, both allowing to determine the electronic structure of the sample, but with different depth sensitivity. The research conducted at PHELIX contributes to the understanding of new materials for spintronics, magnetoelectronics and twistronics, which might create the basis of modern electronics. The samples should be UHV compatible and conducting or well-grounded, with dimensions not greater than 8 mm by 8 mm. They should be firmly attached to the sample holder as the measurements are carried out in a vertical plane. PHELIX has an elliptically polarizing undulator producing different polarizations of light, and the plane grating monochromator with 3 gratings, optimized for different energy ranges, covering 50 to 1500 EVs in total. For X-ray absorption spectroscopy measurements, the sample is set perpendicularly to the beam. The drain current or fluorescence photons are detected. The photon energy is scanned along the defined range using beamline software. Measurements performed with a hemispherical analyzer or a PHELIX spin detector require dedicated software called Prodigy. When the sample normal overlaps the axis of the analyzer's lenses, the beam impinges on the sample at 54.7 degrees. Prodigy allows to control the photon energy of the beamline, all types of measurements with the analyzer and spin measurements, such as energy scans for one point in K-space and spin-resolved maps in K-space for a specific kinetic energy for in-plane and out-of-plane spin components. What is the lowest measurement temperature? The lowest guaranteed temperature is 15 K. What rotations are available for the measurement manipulator? The manipulator offers rotations around all 3 translational axes. What is the energy resolution? It is limited by the beamline, which has 10,000 of the resolving power. For more information, visit the CERIC website.